You know, in medicine, you sometimes find a true hero, a treatment that saves lives against just incredible odds. But what if that hero has a serious flaw, a dark side? Well, that's exactly the story we're diving into today. We're talking about a compound called sodium nitrite, an antidote that's both brilliant and has a pretty dangerous secret.
So let's just think about this for a second. How do you fight a poison that can stop the human body in, well, in seconds? We're talking about cyanide. This stuff is terrifyingly fast. It basically shuts down your body's ability to use oxygen, right at the cellular level. So for doctors, for first responders, the clock is ticking like crazy. The huge question has always been, how do you possibly intervene before it's all too late?
And for a very, very long time, the go-to answer, the main weapon in the arsenal, was a chemical compound called sodium nitrite. This was the stuff. It was a crucial part of the protocol, given through an IV, to literally pull someone back from the brink. For decades, this was the trusted hero in the fight. All right, so how on earth does this stuff actually work? This is where the story gets really, really clever. See, sodium nitrite doesn't just go in and attack the cyanide head-on. No, that'd be too simple. Instead, it does something that's kind of like medical jujitsu. It uses the body's own systems against the poison.
Okay, the key to this whole process is a condition called methemoglobinemia. It's a bit of a mouthful, I know. Now, usually, this is a bad thing. It's a state where your blood is holding on to oxygen but can't release it to your tissues. So, not good. But, and this is the wild part, in the case of cyanide poisoning, doctors actually induce this condition. They cause it on purpose. You're probably asking, why in the world would they do that? Well, there's a very good reason.
Think of it like setting a 4-step trap. Step 1, you get the sodium nitrite intravenously. Step 2, it immediately gets to work, changing some of your normal hemoglobin into that methemoglobin we just talked about. Now for step 3, the really crucial part. It turns out that cyanide loves methemoglobin. It's way more attracted to it than to the parts of your cells it's trying to attack. So the cyanide basically gets distracted, lets go of its real target, and latches onto the methemoglobin instead. And bam, step 4, they form a whole new, much less toxic compound. The poison is effectively captured and neutralized. It's really pretty genius, right?
But, like in any good story, this is where our hero's dark side comes out. I mean, think about it. You're intentionally messing with the ability of someone's blood to deliver oxygen. Even if it's to save their life, that is a huge risk. And yeah, this powerful solution has a really dangerous side. So, what kind of side effects are we talking about? Well, they're pretty significant. The treatment causes your blood vessels to widen, which can make your blood pressure plummet. That leads to things like dizziness, flushing, nausea, all that fun stuff. Plus, the very condition you're creating, methemoglobinemia, is itself a risk if you're not super careful. But honestly, there's one danger that is way bigger than all the others combined.
Because it turns out, in a situation that is actually all too common, using this antidote isn't just a little risky. No, it can be straight up lethal.
And here it is. This is the big one. Sodium nitrite absolutely cannot be used if the patient has also been exposed to carbon monoxide. Now just think for a second. What's a common source of cyanide poisoning? Smoke inhalation. From a fire? And what else is in that smoke? A ton of carbon monoxide. So if you give sodium nitrite to a fire victim, you could actually make their oxygen-starved state even worse with potentially fatal results. This is our hero antidote's Achilles heel, for sure.
So that massive flaw, that Achilles heel, meant that the medical world really needed a new champion, a new hero that could take on cyanide without that deadly cross-reaction. And that, of course, led to the arrival of a brand new, modern alternative. And that new champion is called hydroxocobalamin. Let's just look at this comparison, because it makes everything so clear. Instead of that whole altering the blood thing, hydroxocobalamin just binds directly to the cyanide. Simple. Now look at that second row. Safety with CO. For sodium nitrite, dangerous. For hydroxocobalamin, considered safe. They're both fast-acting, but that safety profile, wow. That is the absolute game changer that made this the new antidote of choice.
Okay, so where does that leave our original hero, sodium nitrite? Is it just gone? Tossed aside for the newer model? Well, not exactly. Its story isn't over, but its role in the story has definitely changed. I mean, the official medical guidance couldn't be clearer. This is a direct quote. This is no longer the preferred treatment for toxic cyanide exposures. Plain and simple. It used to be the frontline defense, the first thing you reach for. But now, that risk of mixing it with carbon monoxide is it's too high, especially when a safer option is right there on the table.
So today, sodium nitrite is more like a hero in reserve. You'll still find it in cyanide antidote kits, all packaged up and ready to go. But it's only meant to be used in situations where the first-choice treatment, hydroxocobalamin, for some reason isn't available. The fact that they even keep it around is a huge testament to how effective it is. But let's be clear, it's the backup plan now, not the main event.
And all this leaves us with a pretty fascinating thought to chew on. The story of sodium nitrate is a perfect example of medical progress, right? A brilliant, life-saving solution is eventually replaced by something even better, even safer. It really makes you wonder, doesn't it? How many other treatments we once considered heroic are out there right now, just waiting in the wings for their one last specific call to action.